Hello and welcome back to the course. In the last module, we went over some of the basic information that you should know to be successful in this course. We defined what Windows is as an operating system, as well as the forensic methodology. We also talk about Windows forensics in a general way and what is the importance of it. So if you haven't watched that module, please pause this video and watch module 1 as it is very important in the following lessons. In this video, we're going to go over a pre-assessment question for module 2, and after that, we're going to cover Windows imaging and analyze the digital and physical structure of the operating system. So, here's a pre-assessment question for you. What is a forensic image? Do you think it's A, a direct copy of a physical storage device, or maybe B, a backup of active Windows folders, or maybe C, a duplicate of the files in the operating system, or D, a Windows restore point? If you said A, a direct copy of a physical storage device, you are correct. We are going to see why next. Imaging is important to preserve original evidence, for instance, if it is a criminal investigation or it might end up in litigation. Since forensic activities typically alter potential evidence like file access times. Ideally, you should immediately make a duplicate image of the original drive and do forensics on the duplicate. This might require installing the drive with the duplicate image in the suspect computer and booting from the duplicate drive. So make sure that the drive used to make the duplicate has the same interface as the original. Label the original and store it in a locked and secure location. A forensics image, also called a forensic copy, is a bit-by-bit, sector-by-sector direct copy of a physical storage device, including all files, folders, and unallocated free and slack space. Forensic images include not only all the files visible to the operating system, but also deleted files and pieces of files left in the slack and free space. When imaging a Windows operating system, the same forensic principles apply as when imaging any other system. We can use even the same tools as physical drive images and logical volumes can all be imaged with dd.exe. If you don't know what dd is, don't worry, we're going to cover it later on this course. Not all imaging and backup software create forensic images. Windows Backup, for example, creates image backups that are not complete copies of the physical device. Forensic images can be created through specialized forensic software. Some disk imaging utilities not marketed for forensic use also make complete disk images. The image is verified using MD5 SOM, WinMD5, or any other similar tool. A MD5 hash or checksum or message digest is a 128-bit summary of the file contents represented by 32 hexadecimal digits. Files with different MD5 sums are different. Only very exceptionally and usually with the intent to deceive are those with the same sums different. On Windows, all files are read in binary mode, as the MD5 sum utilities there do. The MD5 message digest algorithm takes an input, in this case a file, and produces a 128-bit or 16-byte output, which can be represented as a string of 32 hexadecimal values. This output is a fingerprint or message digest for the file. This is a good way to both verify that the file has not been damaged during electronic transfers and also to verify that the file we're getting has not been tampered with. We need to look at the structure of the Windows operating system. The first physical drive is referred to as hard disk volume 0 and subsequent drives as 1, 2, 3, etc. When you're looking for computers on your network neighborhood, you may have noticed that your local drive is represented by 2 backslashes followed by a dot. Please don't forget to check the references and supplementary material, and in the next video we're going to analyze the logical drive nomenclature on Windows and some commands to extract and mount disks.